or the part program is supplied to the CNC machine tool for machining the workpiece. This CAD system also generates a inspection program based upon the CAD data, and that is supplied to the coordinate measuring machine. Now we have understood that the data collecting unit in a coordinate measuring machine is the probe, inspection probe. Therefore, the selection of probe and its positioning in the CMM machine is very critical. Proper instructions must be given to the CMM system for positioning the probe properly, and the path, what is the path to be followed by the probe, at what angle the probe should approach the workpiece. All these instructions should be properly given by the software. And after a part is produced on the CNC machine, the finished part is moved to CMM, and CMM inspects the workpiece using the inspection program. Then the data about the checked part, inspected part, is sent back to the computer. In this diagram you can observe that the inspection program generated by the CAD system is given to the CMM, and the part that is produced using the CNC program is moved to the CMM, and coordinate measuring machine inspects the workpiece using this CMM program, and the data on the inspected workpiece is sent back to the CAD system for making necessary correction. If there is any deviation in the workpiece from the desired size, that data is utilized to alter the CNC program so that the error is minimized or error is nullified. The data about the checked part is sent back to the computer, where the original part geometry is stored. The part geometry as designed is compared with the part produced, and the resultant deviation, that is error data, is identified. This helps in identifying problems in manufacturing and eliminating problems in manufacturing. Now let us move to another topic, very interesting topic, known as portable coordinate measuring machine. In the previous discussion, we studied about the various configurations of coordinate measuring machine, how the measurement data is obtained, what are the different types of probes, and then we also learnt about the software, CMM software, and we learnt that the coordinate measuring machine will be set up in the metrology lab, or if it is a shop floor CMM, it is moved to the shop floor and it is placed in the production line. The workpieces to be inspected are moved to the table of CMM, and then inspection is carried out. Sometimes if the workpiece cannot be moved to the table of CMM, that means we have a very huge workpiece, very huge casting which cannot be placed onto the table of CMM. In that case, the CMM itself is moved to the part, then it is called portable CMM. In this illustration we can see the various elements of portable CMM. We have CMM system. This is a dual camera system. You can observe the two cameras here, and this is a mobile unit. We can see the wheels. It can be moved to the place where the huge workpiece is placed, and then this is installed or placed near the workpiece. And then we have an optical probe. This is a non-contact type probe, wireless probe. this probe we have to move around the workpiece. The CMM system, dual camera system, will be monitoring the workpiece as well as the probe. Probe movement as well as the workpiece will be continuously monitored by the dual camera system, and then it establishes dynamic referencing using optical triangulation technique. And then this optical probe it takes the images from the workpiece, and then that data is sent to the data acquisition, storage, processing and display system. There is a dedicated computer system with the software. All the data obtained by this optical probe is transmitted wirelessly to this data acquisition system. This system, after acquiring, it will process the data, and then the results are displayed in the monitor. Now, what are the features of portable coordinate measuring machine? So these portable CMM, they are currently used on production lines of automotive, aerospace and manufacturing industries. They are insensitive to changes in the environment. That means the vibrations of the workpiece because of the nearby installations and part displacement, and then setup or CMM instability have no impact on the measurement. These portable CMMs, they are highly efficient at measuring parts that can't be moved to a granite or cast iron table. They are very much ideal for geometric and surface quality control. These portable CMMs offer scanning capabilities when paired with a 3D scanner. The part size, the workpiece size ranges from 1 meter to 3 meters, and any type of material can be inspected, like hard material or very soft materials can be inspected. Since they are this is non-contact type of measurement, even very soft materials can be measured without any difficulty. The measurement range can be extended up to 10 meters. So in this picture you can see the CMM system. This is the mobile CMM system, and this is the huge workpiece which is to be inspected, and then we have a wireless probe. Both the probe and the workpieces are monitored, are continuously viewed by the dual camera system, and then the image captured by the wireless this vision probe is sent to the computer system for processing. Now, optical triangulation technique is used for dynamic referencing. This is required for self-positioning or dynamic referencing of the workpiece and the probe system. This dynamic referencing enables the measuring device to be continuously locked to the part by an optical link. Now, cameras in the optical localization system can simultaneously observe the targets positioned on the probe and object. That means the targets, are, in other words, reflectors, are placed on the workpiece to be inspected, and also they are placed on the probe. And these targets and reflective surfaces, they are continuously observed by the cameras. Since the targets are measured at the same time, the targets placed on object and targets placed on probe system, they are measured at the same time. It is possible to calculate not only the probe position but also the part position at the same time. Now, this illustration shows the dynamic referencing. we have this dual camera system which will be continuously monitoring the workpiece as well as probe system or scanner system. Now this is the workpiece to be inspected. You can observe that the targets or reflectors are placed at specified locations on the workpiece to be inspected, and also on the scanners reflectors are placed, and then reflectors are placed on the probe system also.